Hello, how are you guys doing? Today we're going to be talking about simple and compound substances. We will introduce the word element, but what is an element? Let's see in the next video.
Did you know when you are breathing, you are actually inhaling elements? The air you breathe is made up of many elements like oxygen, nitrogen, and argon. Elements are everywhere. They are the building blocks of everything on Earth. Your dog, the mountains, your car, your eyes, and yes, even beer. In this lesson, we will discuss what an element is, how elements are written as symbols, and how they are the building blocks of all matter. An element is a pure substance that cannot be broken down by chemical methods into simpler components. For example, the element gold cannot be broken down into anything other than gold. If you kept hitting gold with a hammer, the pieces would get smaller, but each piece will always be gold. You can think of each kind of element having its own unique fingerprint, making it different than other elements. Elements consist of only one type of atom. An atom is the smallest particle of an element that still has the same properties of that element. All atoms of a specific element have exactly the same chemical makeup, size, and mass. There are a total of 118 elements, with the most abundant elements on Earth being helium and hydrogen. Many elements occur naturally on Earth, however, some are created in a laboratory by scientists by nuclear processes. Instead of writing the whole elemental name, elements are often written as a symbol. For example, O is a symbol for oxygen, C is the symbol for carbon, and H is the symbol for hydrogen. Not all elements have just one letter as a symbol, but have two letters. Like Al is a symbol for aluminum, and Ni is a symbol for nickel. The first letter is always capitalized, but the second letter is not. Symbol names do not always match the letters in the elemental name. For example, Fe is the symbol for iron, and Au is the symbol for gold. These symbol names are derived from the Latin names for those elements.
So guys, everything around us is made of matter, and all matter is composed of elements, either single elements or combinations of elements called compounds. Elements are substances that cannot be separated into simpler substances. They are the building blocks for all the rest of matter in the world. An element is a pure substance that is made from a single type of atom. But what is an atom? The smallest particle of matter are called atoms. Let's say that you are chopping a carrot into smaller and smaller pieces. You would reach a point where you could not cut up the carrot anymore, but you still have the carrot, right? You would then have molecules of carrot. The same applies to elements. If you cut up a piece of aluminum, you would reach a point that you could no longer divide it. These are aluminum atoms. So an atom is the smallest particle of an element. Elements again are pure substances, and there are currently 118 known elements on Earth. These elements are grouped in a periodic table. This periodic table, as you can see in slide, is an important way of learning and understanding elements. You can see the 118 elements with their symbols. In the periodic table, each element has its own name and symbol. Some of the symbols are easy to remember, so chemists use symbols to represent elements. A symbol is a letter or picture used to represent something. They use one or two letters to represent elements. We use the symbol Hg for mercury. Mercury is a liquid silver that is highly poisonous and that is used in thermometers. We use Au for gold and C for carbon. That's right. So we talked in previous lessons about ways of that carbon is formed in nature when organisms die, they will be decomposed by decomposers, and we will get the carbon element in the soil, right? So we use the symbol C for carbon. The coin shown in this slide is made of bones, but bones isn't a single element. It is made by mixing two elements together, copper and tin. And as you can see, CO for copper and SN for tin. We use the symbol Al for aluminum. The symbol for oxygen is O. O stands for one atom of oxygen. As we said, that some symbols are easy to remember, like H for hydrogen, N for nitrogen. Can you please take a look on the H2O molecule? Is it made of one element? What does it have? How many symbols? We can see the hydrogen symbol in it, and we can see the oxygen symbol in it. So the H2O substance isn't a single element. Okay, so it has two different types of atoms. It's not a single element. It has two elements combined together. What about the ozone? O3. How many types of atoms is there in this substance? O3. So we have one type of atoms. It's the O. We can see the symbol of the oxygen only, right? So this is considered as an element since it's made entirely from one type of atom, right? That's your knowledge. Let's try together to name the element used to fly the balloon. What is the gas that can lift things in the air? What do you think? It's helium. That's right. So the helium is an element that is used to fly the balloon. The symbol of helium is He. What is the element used to make this tool? What is this tool made of? It's made of iron. Excellent, good job. The iron is an element and the symbol of iron is Fe. Here is an easy one. What is the element used to help the divers breathe? Oxygen. Good job. What's the symbol of oxygen? Oh, perfect. So oxygen. The oxygen is the element used to help the divers breathe underwater. What is the element that makes this ring? What is this ring made of? Gold. Do you remember what is the gold symbol? Au. Good job. So helium, He, iron, Fe, oxygen, O, gold, Au.
When two or more elements combine, we've got a chemical compound. Let's take a look at the element O, or oxygen, found on the periodic table of elements. Oxygen is just one type of atom. Here we represent this atom with a blue circle. Another element found on the periodic table of elements is hydrogen. Hydrogen is just one type of atom that we can represent with a red circle. Now, let's take two hydrogen atoms. We will combine these two hydrogen atoms with one oxygen atom. This is a chemical compound known as H2O. H2O is better known to us as water. Water contains two hydrogen atoms and one oxygen atom that have been chemically combined. Carbon is another element found on the periodic table of elements. Carbon is just one type of atom that we represent here with a yellow circle. Oxygen, once again, is found in the periodic table of elements and is just one type of atom that we will represent with a blue circle. Let's take two oxygen atoms and one carbon atom. When these three atoms combine, they form a chemical compound known as CO2. CO2 contains one carbon, two oxygen atoms. This compound is better known as carbon dioxide. Carbon dioxide, one carbon atom and two oxygen atoms chemically combine. Chemical compounds, when two or more elements combine.
A compound is two or more different elements chemically bonded together. Believe it or not, compounds are all around us. Water, salt, and sugar are examples of compounds. In the water case, hydrogen atoms are bonded to oxygen atoms.
So atoms make up absolutely everything in the world around you. Today we're going to be using these small molymod balls as a model for an atom. Obviously atoms are way smaller than this, but we're going to use this as our model today. What you can see that I've got here is several different types of atoms, and if we organize them into sections of the same type of atom, we can then call those elements. Now surprisingly, there's only actually 118 elements that have been discovered so far, and you'll find all of them on your periodic table. An element is defined as something that is only made out of one type of atom. So if it contains any more than one type of atom, then it cannot be classified as an element anymore. Check out these examples. Which one do you think are elements and which ones do you think are not elements? Pause the video here, see if you can work it out. The key thing for you to realize here is that it doesn't matter how many atoms it contains as long as they are all of the same type, or in this case the same color. So what you've got is these three at the top here that all contain only atoms of one type. All of the ones at the bottom all contain more than one different type of atom. They all have multicolored molymod balls. The question you might be asking now is, what do we call the three at the bottom? So the top three are elements. They contain one type of atom. The bottom three contain two or more types of atoms. They have different colored molymod balls. We call these compounds. And compounds have to be chemically combined and contain two or more atoms.
The difference between a molecule and a compound. A molecule is formed when two or more atoms join together. A compound is a molecule that contains at least two different elements. So, a molecule can consist of two or more atoms of the same element joined together. But a compound must always have at least two atoms of different elements joined together. Therefore, you can say that all compounds are molecules, but not all molecules are compounds. For example, oxygen gas is not a compound because it only consists of one type of element. But carbon dioxide is a compound because it consists of atoms of different elements joined together, carbon and oxygen.
Again, guys, a compound is a substance formed when two or more elements are chemically joined. Chemical compounds are formed when elements are joined by chemical bonds. These bonds are so strong that the compound behaves like a single substance, a new substance. What does this mean? When the elements are joined, the atoms lose their individual properties and have different properties. So the compounds have their own properties that are unique from the elements they are made of. Let's take the water as an example. Water is a liquid, and water is made of oxygen and hydrogen. Both oxygen and hydrogen are gases. So oxygen and hydrogen lost their individual properties, and the water is behaving as a single substance, a completely new substance with its own properties. What about salt? Salt is a natural mineral that is found on Earth. The salt that we eat, guys, consists of 40% sodium and 60% chlorine, joined together chemically to make a compound we call salt. The sodium is a silvery solid that reacts with water. The sodium has an AS symbol. While chlorine is a green poisonous gas, and we use Cl as a symbol for chlorine. Both sodium and chloride aren't safe by themselves, but when they join together, they aren't dangerous, and they make the sodium chloride, which is salt. So since salt is made of sodium and chloride, its scientific name is NaCl, also called sodium chloride. So as we said, when the elements in here, when sodium and chlorine are joined, the atoms lose their individual properties and have different properties from the elements they are composed of. So the sodium chloride, which is the salt, is behaving like a new substance.
To write the formula for carbon dioxide, we'll first write C for the carbon, and then we have the oxide, that is the oxygen. We can see that we have two nonmetals, carbon and oxygen. That means it's going to be a molecular compound. And we also see this di up here. Di, when we see a prefix like that, tells us that we have a molecular compound as well. So we only have one carbon, so we leave that as C. And then oxygen, we have the di. That means we have two. And that's the formula for carbon dioxide. This is Dr. B, and thanks for watching.
Nitrogen dioxide is a chemical compound. What is the first word used to name this substance? Why, nitrogen. What does that mean? It means that nitrogen is part of this substance. Let's see. What does the prefix di mean? Dioxide. What do we mean by di? Di means two. Okay? Where does the part oxide come from? From oxide, oxygen. That's right. So what are the two elements that combine to form the substance nitrogen dioxide? Nitrogen and oxygen. That's right. So nitrogen dioxide contains nitrogen and oxygen. Nitrogen dioxide is a brownish gas. It shocks when it's breathed in. Nitrogen dioxide is very toxic. It's released by some cars polluting the atmosphere. It has a bad odor, and it can stop the nose from smelling, making the person unaware that they are breathing toxic fumes.
Salt water, a transparent bowl, 2 glass test tubes, a 4.5 volt battery, 2 twin wires with alligator clips, colored plasticine, 2 pencil leads. Connect one pencil lead to the wire by means of the alligator clip. Then seal the connection with plasticine. Repeat this procedure with the other lead. Fill the test tube with water and insert the pencil leads in them. Be careful not to let air bubbles into the test tubes. Attach the free terminals of the wire to the battery. Do not forget which clip you have connected to the positive pole, that is shorter, and which to the negative one. After a few minutes, you will notice that small air bubbles have developed on the surface of the leads. After 3 hours, there is a lot of gas in the test tubes. However, in the test tube connected to the negative pole, there is double the amount of gas respect to the other. Why? Electricity breaks down water molecules, freeing the oxygen and the hydrogen that compose it. Hydrogen gas, H2, forms around the negative lead, while oxygen gas, O2, forms around the positive one. Every 2 water molecules broken down by electricity form 2 hydrogen gas molecules and only 1 of oxygen gas. For this reason, one test tube has double the amount of gas respect to the other.
We've been told, guys, that water is made up of hydrogen and oxygen. But how do we really know that? Can this wet substance really be made of 2 gases? We try to separate water into oxygen and hydrogen using electrolysis. Electrolysis of water is the decomposition of water into oxygen and hydrogen gas. This happens when an electric current being passed through the water. This technique can be used to produce breathable oxygen and hydrogen fuel. So what happens? Bubbles of gas quickly start to form at each electrode. We have the hydrogen gas that starts to form at the cathode, which is the negative electrode, and the oxygen gas forms at the anode, which is the positive electrode. And we have more gas that is collecting at the negative electrode than at the positive electrode. Scientists have been learned how to use the power of electricity to split elements and compounds. How do we call this technique? Electrolysis, right. So during electrolysis, an electric current passes between 2 electrodes. An electrode, guys, is something that conducts or carries electricity. And we have 2 different electrodes. One of them has a negative charge, which is the cathode, and the second one is positively charged, which is the anode. Hydrogen forms at the cathode while the oxygen forms at the anode. Okay? Since one molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen, do you remember the H2O symbol? So we have 2 atoms of hydrogen and 1 atom of oxygen. So the volume of the hydrogen produced will be double the volume of the oxygen produced. So we can tell that the gas formed in this tube is the hydrogen, since the volume of this gas is double the volume of the gas in the second tube, and the second gas being formed is the oxygen. This one is the oxygen. Okay, so the volume of the hydrogen formed in the first tube is double the volume of the oxygen formed in the second tube. And we can now identify the 2 types of electrodes. This one is the cathode. Since we said that hydrogen forms at the cathode and this one is the anode, since oxygen forms at the anode, okay? But what is one way to test for the gases produced? How do we know that the gas formed are oxygen and hydrogen? Okay, we test for oxygen with a glowing splint. Okay, if enough oxygen is present, the splint rekindles. So you will bring an extinguished flame and oxygen will relight it. Okay, this will confirm that this gas is oxygen. But hydrogen is explosive. It will make a cool popping noise in the presence of a lighted splinter of wood. Okay? So when you put a burning splint near the mouth of this tube, it explodes with a pop sound, reduced form. Okay? The very small explosion extinguishes the flame. This gas is hydrogen.
All right. Get your hand one out of the way as soon as you do.
Yay!
Let's try together to read the water electrolysis diagram shown in this figure. As we said, during electrolysis, an electric current passes between two electrodes, and we have two different electrodes, the cathode and the anode. Right, good job. Which of the electrodes has a positive charge? The anode, excellent. So this side will find the anode, that's right. While the cathode has a negative charge. So this side will find the cathode. What about the gases? This is electrolysis of water. We are splitting water compound into its elements, hydrogen and oxygen. But which of the gases X and Y is the oxygen and which one is the hydrogen? There are two ways to find out the answer. Okay, let's check. The volume of gas Y is bigger or greater or double the volume of gas X, right? So gas Y is hydrogen. Perfect. This is hydrogen. Since the volume of hydrogen produced is double the volume of oxygen produced, one molecule of water has two atoms of hydrogen and one atom of oxygen. So during electrolysis, the volume of hydrogen produced is double, is twice the volume of the oxygen produced. Another way to determine the gases is to look at the electrodes. We said that the hydrogen forms at the cathode while the oxygen forms at the anode, right? So we can tell that gas X is the oxygen since at the positively charged anode the oxygen is generated. Okay? And that's it. We finished. This is our lesson. You should be able now to define an element and a compound. Do you know what's an element? What's a compound? Do you know how to write in symbols some of the elements? Gold, copper, aluminum, oxygen, nitrogen, and other elements? Can you tell different examples of elements and compounds that you can see in your daily life? Can you draw models of some everyday compounds? What about salt? Isn't it NaCl? Water, H2O? Carbon dioxide, CO2? Nitrogen dioxide, NO2? What is one way to break or to split a compound? Electrolysis, that's right. So if you still have any questions, dear one, I'm always available to answer all of your questions. Stay safe. I love you so much. I can't wait to see you again. Bye-bye.